Okay, let's try to understand this function notation. It can be a difficult concept to make sense of. Let's get started with a picture. I often like to think of functions as machines. So for example, let's look at this machine and let's call it f for function. And let's say we feed something into it, some sort of input. We have an input that goes in, and of course f does its magic inside that we can't see here, and out comes the output of the machine f. Okay? Now typically in math, the input is the variable x, and the output is an expression, let's say. It's an expression usually containing x. Okay? Now this entire expression is usually called the y value. So you have an x as your input and a y as your output. And y equals the expression containing x, the entire expression. Okay, so let's take a specific example. Let's look at the example where f is the machine. Let's call it the add to machine. Okay? So here's f. Let's say our input to the machine f is x. Then think about what its output would be. Its output would not be x. Okay? X is just a variable. When x comes in, then what would come out? X plus 2 would come out. Okay? What I want to point out here, this is the tricky part, x here is arbitrary. So think about what you could feed into this machine. In other words, what can you add to? For example, 5 you could add to, and the output would be 7. So if 5 went in, then 5 plus 2 would come out. So this x here is just a placeholder. That's all it is. Okay? So all it's saying is if x goes in, then x goes right there in your output, and then it's added to 2. Okay? So another way to look at this, another way to write this machine definition, this add to machine definition, is like this. F of x is how this is read. It means that x is the input to the machine f. So x is input to the machine f, and the output, f of x is the output, equals x plus 2. Okay? So if x is the input to f, then x plus 2 is the output. This is usually the definition of the function f. So typically when you see f of x equals, that is the definition of how the machine works. It tells you what f does to any input x. Okay? So let's take another example. So remember what we said before about x is just a placeholder. Now I could ask you for something like f of 5, as I mentioned before. This means x is 5, and it's asking for the output. In other words, what is y? Okay? So we know x equals 5. What does the output y equal? Okay, so here's the idea. We use our function definition from above. Here's our definition that we always go back to. F takes x and sends it to x plus 2. So f takes 5 and replaces this with a 5 and replaces this with a 5. Okay? So f of 5 equals not x plus 2, but now x is 5, so 5 plus 2, which of course is 7. Okay? So in this example, the y value is 7 when x is 5. Okay, good. You could also ask for a more complex expression, such as what is f of a plus h? This is a common one. F of a plus h means we replace this, our input, with a plus h. So we go back to our definition right here. Instead of x being the input, a plus h is the input. So f of a plus h equals a plus h plus 2, which you can drop the parentheses on the a plus h because if you recall, any parentheses with nothing next to it has a 1 next to it that you can distribute. So 1 times a is of course a, 1 times h is of course h, plus 2. So the output of a plus h is a plus h plus 2. And that makes sense. This is the add 2 machine. Okay, let's try a harder function now. F of x equals x squared plus 2. Again, x is just a placeholder to show you where it goes in the output. So what if I asked for something like f of a plus h now? Well, f of a plus h means my input to the function is a plus h, so I replace all my x's with a plus h, which then gives me a plus h squared plus 2. Now we can try to simplify this, and I will do it just to show you, review some basic algebra techniques. A plus h squared is the same thing as a plus h times a plus h, and then I've got the plus 2. Alright, now I need to multiply this out, so I have to distribute a times a, which is a squared. Then I do the a times the h, which is ah, and then I do this a times h, which is another ah. That gives me 2 ah. Finally, h times h is h squared plus 2. So this is the output when a plus h is my input. So f of a plus h equals a squared plus 2ah plus h squared plus 2. Now let's look at how to use this same function definition for two different inputs, such as f of 3 minus f of h. F of 3, I take 3 and input it to my function, so I get 3 squared plus 2 for f of 3. Okay? And let's work on f of h. F of h, my input now to the function is h, so I replace my input up here, h squared plus 2. So now I can say f of 3 minus f of h equals 3 squared plus 2 minus h squared plus 2. And now I can just simplify this. 3 squared plus 2 is 11, minus h squared plus 2 I can't add, they're not like terms, so I need to remember to distribute my negative, which gives me negative h squared minus 2. Now I can combine the 11 and the negative 2 to get 9 minus h squared. So f of 3 minus f of h takes two different inputs to the same function and just looks at the difference between those to get 9 minus h squared.